3.3 Rules of differentiation. The first rule is called the constant rule. For the function f of x in the form of fx equals c, as we consider this as a straight line or the horizontal line, the slope of the horizontal line is 0. Therefore, the derivative of the constant function is 0. Derivative at the slope of the tangent line. The power rule, f of x is x to the power n. The derivative of this function is n times x to the n minus 1. Exponential rule, f of x is e to the x. The derivative is e to the x, so no change. Next, the concept multiple rule. If f of x is c times the function g, the derivative is c times the derivative of the g, or c times g prime. Sum rule. The derivative of the sum of the two functions is the sum of the two derivatives, which is similar to the difference version of it. So the derivative of f minus g is the same as the difference of the derivative of the f and the derivative of the g. The higher order derivatives as y equals f of x, y prime is f prime, or in the form of dy by dx. To find the higher order derivative as f prime or the second derivative, we use two dashes. So f double prime is the second derivative of the function f, or use the notation d2f dx squared, which is from the derivative of the first derivative. Another notation is d2y dx squared, or another form which is easier to use is y double prime. For the third order or the third derivative, it can be found by finding the derivative of the second derivative. After the third derivative, from the fourth derivative, we are going to use the superscript with the parentheses around the order. So f superscript 4. This one means the fourth derivative. For the first, the second, and third, we can use the dash or dashes or the three dashes for the third derivative. And after that, we are going to use the general notation as f to the superscript 4. Make sure the number 4 or the nth derivative there in the parentheses. Examples. Number 1, find the first and second derivative. Part A, f of x equals e to the second plus x to the power 100. Consider each term. E to the second. This one e as a constant. Power 2 is another constant. So the e to the second is the constant function, where x to the power n is the power form. When you see the power or x to the power as the real number, the power n is 100. So we are going to apply the rules like for y equals c or the constant rule. So y prime equals 0. For y equals x to the power n, the y prime is n, x to the n minus 1. So for the first derivative of the f prime, the derivative of e to the second, which is d by dx of e to the second, plus the derivative d by dx of x to 100. The first one, as the derivative of the constant equals 0, we get 0. The second part, derivative of x to the 100. As the power n is 100, apply the power rule. We get 100 multiplied by x to 100 minus 1. Therefore, the derivative is 100 times x to the power 99, or just 100x to the 99 for the first derivative. And then we find the second derivative, or f double prime, as by the d by dx of 100 x to the power 99. For this situation, we have the constant 100 multiplied by the power function x to the power 999. So this is the same as 100 multiplied by the derivative of x to the power 99, as we use the constant multiple. Therefore, the second derivative of the f with respect to x is 100 multiplied by the power 99 times x to the power 99 minus 1. And finally, we get 9900 times x to the power 98 as the second derivative of this function f. Example B. Part B, f of x equals x to the third over 2 plus 4 times x to the power 1/2. We rewrite it in a form that's easier to identify the type of the function. As the first term, we can write it as 1/2 times x to the power 3. The second term as 4 times x to the power 1/2. For the derivative, the first derivative, or f prime, is the derivative of 1/2 times x to the third, or we write as 1/2 times the derivative of x to the power 3 plus 4 times the derivative of x to the power 1/2, and then apply the power rule for both x to the third and x to the 1/2, with the coefficient 1/2 and 4 remain the same. So 1/2 multiplied by 3 x to the power 3 minus 1 for the first term. The second term will get 4 times 1/2 x to the 1/2 minus 1. Simplify the numbers. We will get 3 over 2 x to the power second plus 2 times x to the power negative 1 over 2 as the first derivative. And then to find the second derivative, apply the constant multiple and also the power rule, similar to the way that we found f prime. So 3 over 2 as a coefficient, and find the derivative of x squared plus 2 times the derivative of x to the power negative 1/2. The first term, 3 over 2, multiplied by, after applying the power rule, the derivative of x squared with respect to x, we will get 2 times x to the power 2 minus 1, plus 2 times, applying the power rule here, we get negative 1 over 2, x to the power negative 1/2 minus 1. And then simplify the numbers. 2 and 2 reduce, we get 3 times x to the first power. 2 and 2 reduce, becomes negative 1, x to the power negative 3 over 2. And this is the second derivative of the f. Part C, f of x equals 1 over x squared. plus 3 times e to the x plus the fifth root of x squared. Recall, we have the power rule, we have the constant multiple rule, we have exponential rule. We do not have the reciprocal rule or the radical rule. Now we are going to rewrite terms as appropriate to fit with the form that we can find the derivative using the available rule. The first term, 1 over x squared, write it as a power function, so we get x to the power negative second, minus 3 e to the x for the second term, and the third term, we would get x to the power 2 over 5, as the numerator of the power represent the power in general, and the denominator of the exponent is the index of the root, which is the fifth root. The first derivative, we find the derivative of x to the negative second, applying the power rule. Negative 2, x to the power, this one is, the n is negative 2, the power rule. The third term, n is 2 over 5. Applying the power rule for x to the power negative second, we get negative 2, x times x to the power negative 2 minus 1. The second term is the constant multiple exponential function. The derivative of the exponential function remains the same form as the function form. So the derivative of negative 3 e to the x is negative 3 e to the x. The third term, the derivative of x to the power 2/5 is the power 2/5 as a coefficient multiplied by x to the power 2/5 minus 1. And then simplify the power to be negative 2 x to the power negative 3 minus 3 e to the x plus 2 over 5 x to the power negative 3 over 5. And then we continue to find the second derivative. The second derivative is the derivative of the first derivative. So the coefficient negative 2 multiplied by the derivative of x to the power negative 3, or negative 3 x to the negative 3 minus 1, minus 3 e to the x, which is the same as the derivative of the exponential function is the same form as the exponential function, e to the x. The third term, coefficient 2 over 5, multiplied by the derivative of x to the negative 3/5. The power becomes a coefficient. The new power is from negative 3 over 5 minus 1. Simplify the power and adjust the product of the coefficient. Negative 2 and negative 3 multiply to be positive 6. X to the power negative 4th minus 3 e to the x. The last term, 2 times negative 3, gives us negative 6 over 5 times 5, 25. X to the power negative 8 over 5 as the second derivative of this